Okay, here we go. Good morning. Welcome back. It's a Monday morning for me, and I'm gonna just switch over to my screen here. There we go. And yeah, let's dive right in like I normally do. It's the way I do things. Except I kind of forgot where we left off. We were in the middle of trying to convert. Oh, that's right. We were trying to move the parser over into a ref cell so we can make it a separate thing. And I'm not too sure I want to keep doing that because it's getting messy. So I've been thinking about it a little bit. Instead, let me just reset this. Let's undo all of that. Boom, done. No regrets. If I take a look at the compiler as it is, I think what we were in the middle of trying to do was generate this this code here, the function declaration code. We had gotten as far as this stuff here, except we didn't have to change runtime error. And VM. It's here at the bottom. Yeah, so we were changing it to do call frames instead. Okay, so I skipped ahead for this. I think we did this, right? FN interpret. I remember typing this in. Yeah, so we pushed the stack thing, we pushed on the call frame, and then we had to change the error, the runtime error, which we didn't do, to report the line of code that's on the call frame. That's the error. And I don't know why I skipped over that. Oh, it's probably because I was trying to get right into this function declaration stuff. So let's take a look at what our git log shows. So it says 24.3 call frames. So let's do this and add that to the call frames. And then let's dive into function declarations. And I think what we need to do is slightly different to the direction I was going last time. Oops. Declaration. Yeah, so I undid that with the git checkout. All right, so let's fix this. Call frames count -1. So that's just getting the last frame right here. And then getting the instruction it's on, and then getting the line number. Okay, so that shouldn't be too hard. All right, so we still print out the error message. That's this line here, or fputS is the new line for this, which I put as part of this to make it easy. And then we have this line in script. And now it's saying replace these two lines with getting the call frame to get the line number. So we can just do that this way. We can say get the call frame by saying let frame equals. Oh, yeah. So that's what we did here. Get chunk already does all of this work for us. Okay, so we don't have to do any of that because we already have the chunk that we can get. And then we can just say IP -1 to get this. And then we can just get the line number directly from that. So we've already done it, essentially, just by moving everything into the chunk. Okay. Sorry for the distraction. So here's what I'm thinking with the compiler. The compiler contains the parser and the scanner. Those don't change when we enter a new function. And remember, the reason I'm going through this is because we have this new function to parse the function. We create in the C version, we create a new compiler, we initialize it, and then what we do is we kind of cheat by having a chain of compilers. He says a stack, but it's a linked list of compilers, saying that this is the current one, and then reset it back to the enclosing one. So this enclosing really just creates this linked list. And what's the point of that? The point of that is to basically initialize the current one on the chain of compilers, and then compile from begin scope to block the function that we're in. We end the current compiler, and then in end compiler, we undo the chain link we had in there. So I thought about this for a little bit, and I said, what do we need to actually do? What we actually need to do is chunk this guy here, the current function, and the locals, and the scope depth. All of these guys are part of the new compiler, or the compiler that we need for the function. The rules are just those actually should be a static, but we're creating them every time we create a compiler, because I didn't want to import the lazy static crate. So we have the rules, we have the parser, we have the scanner, and then these four guys here, and we're not actually using this except for the debug code. Let me move him to the bottom. We might end up using it later, I don't know. So I figured that these three lines here make up the actual compiler. And so what we can do is these three lines make up the result of what gets compiled. Right. So in this thing here, what I want to do is say replace. I want to have this here. If I can create I don't know, what should we call it? Result. And this will be a ref cell of the actual compiler result. That's a bad name for it. And then these three would move into this compile result, and then we can just say push a new compile result here. We do the compilation and then we pop it here, and that might work. So I'm going to give that a try, and what I'm going to do, I think the best way to do it would just be to do it one at a time. Struct compile result. So if we can move the chunk here, and it still needs to be in a ref cell, right? Because it needs to be, we need interior mutability. So let's see what we can do with this. And now what we can do, so we're basically refactoring these three, and probably this guy as well, out of here. Hang on, I need to adjust my headphones here. There we go. Okay. So now with this change, we have this result. There's got to be a better name for it than result. And now if I try to compile this, everything is going to break, but we can fix it one at a time. Right? I have the rules. I put the rules up at the top, and I want to say for chunk, instead of chunk, I want to say result, ref cell new, compile result. I guess we can create a default. It can be completely empty. Does chunk have default? It does not. And these two do. I don't think value array does. It does now. Okay. So now every place we have this self chunk replace or whatever, self.chunk, we have to change it to self.result.borrow. And actually that one has to be bar mute, but I'm going to change it to just borrow, because I'm going to do that. Because we have to do a double borrow now. That's annoying. I can fix that by implementing something inside. So I'm just replacing all of them with result.borrow. And then what I do is create an impl. Yeah, this has to be bar mute. This one has to be bar mute. Dot. Oh, interesting. Oh, borrow dot chunk. Yeah. That's what I needed to replace it with. Now what is this? This is the compile function itself. So we need to actually put in a new result. So I should have been paying attention to what's going on here. This should be compile result. And this should be result. And we need to extract the chunk. Let chunk equal result dot replace. Right? Result dot chunk dot replace chunk new. Oh. Default. Okay, and now each one of these has to get chunked. So I'm actually, before I do all of that, what I can do is modify the result type to take all of these things in. So let's do that. We can say impl compile result, and we can define a write function for it. We still need to borrow, but self, and then it takes a byte, which is going to be U8, and then it's going to take a line number, which is a usize. It doesn't return anything, so then self chunk borrow mute write byte line. So then this, oops. So then all the writes change to this. Just borrow, I think. Let's see. Yep. Okay, so this one becomes count. That's easy enough. Count self. And it returns a, I guess a usize. A U8. What are we looking for here? I guess a U8. Self dot chunk dot borrow dot count. And this is just this. Oh, it doesn't like that. Expected U8, found usize. Okay. Easy enough. This also. And then add constant. Okay, we can redirect that. Then add constant. Self, and then value is a value. And it returns an option U8. Self.chunk.borrow mute dot add constant value. Oops. Value. That should automatically do that, so we can get rid of that. That one we can get rid of, we already fixed, and then we have write at, okay. And that takes an offset, which is probably usize, and then a byte, which is U8. Okay, and then doesn't return anything. Self chunk, borrow mute, write at, offset byte. Disassemble. Okay, that's easy. Disassemble. That's all. Oh no, it takes a current function, which is going to be a two-stringable thing. Let's take a quick look. Nope, chunk. Yeah, it takes a two-stringable thing. Okay. Yep, and it doesn't return anything, and then just self chunk borrow disassemble name. And I'll get rid of one of those. Lots of counts. Okay. All right, so we're back to parity with what we had before. That's not too bad, right? And then, so what did this give us the ability to do? It gave us the ability to swap in an entire thing. So we should be able to move the locals down now. Right, so we refactored the chunk. Now we're going to refactor the locals into here. That's also going to be in a ref cell. So locals, I guess we can do it this way. That comes out of here. So instead of this, we're going to do a self result borrow push local. Right, and then we can put that in here. Push self and local. Right, and then self locals borrow mute push local. So let's see, does that like that? It does. Okay. Now what's going on here is we're checking the locals to see if the length of the locals is greater than 0 and the scope depth is greater than the last local's depth. So we can actually, oh, that's right. So yeah, let's move the scope depth down in here as well. That way they're both moved at the same time, because then we could just write a function which does these two things. And I don't know, call it remaining scope. Scope. Is scope poppable? That's a terrible name too. I'm bad at naming. And that's all we care about. We can just return a bool. And we can do all of this here. We can say self locals borrow len is greater than 0 and self locals borrow last unwrap depth unwrap is greater than self scope depth. Right? And that way we moved both scope depth and this in here, and then we just change this to say while self is scope poppable. And that's the whole thing. So that simplifies the code a little bit there. And then we'll have to change this pop business here. Let's write that. Fun pop self. It doesn't return anything, so it's just self locals borrow mute. We ignore it. We ignore the value we pop off anyway, so it doesn't matter. Let's do that, and this becomes results borrow pop. Okay, len like that. And right, we don't have scope depth anymore. I'm gonna have to change all of those. Results dot inc scope, we'll call it. Where can that go? Inc scope self. It's got to be in a ref cell. Which means this has to be borrow. Which means we say self. Oh, I did that backwards. Like that. And then inc scope becomes self scope depth borrow mute plus equals 1, like that. And we're going to need a deck scope as well, which is minus equals 1. That goes away, and here's result deck scope. Oh, didn't like that. Oh, I have to borrow. That's the one annoying thing, is this extra borrow we have to put everywhere. Wow. Okay. I could actually do it the way I had it there and just put the function in here, but that's all right. Oh, this one's a little tougher, right? We're going to have So what is this doing? This is just looking for a variable name, and it gets back whether or not the variable exists. If the variable exists but's not initialized, then we have to report this error. If it exists and it is initialized, then we just return the stack depth that we have to go down. If it doesn't exist at all, we return a none. So this returns 3 different things. So I'm going to get rid of these comments. I don't know why I left them there. Okay. I think this just becomes like find variable, and we give it a lexeme, a string, and then it's going to return a find result, because we're going to return one of 3 things. What are those 3 things? Enum find result. We can either return the fact that it's uninitialized, it's not found, or it has a specific depth, like that, right? So we can return one of those 3 things, and then basically just steal this code. And this becomes match find self result borrow find variable name.lexeme, probably this name.lexeme, like that. And then it's going to be a find result uninitialized. Wow, I gave myself a tough time here. It's going to do something. Find result of not found is going to return a none, and find results of depth of D is going to return some D. This is going to also have to return a none as well. Oops. None as well, but before we do that, we have to report the error. So let's do that. Okay, that's straightforward. And then this all stays the same except this self locals borrow len minus e minus 1 as u8. We don't have to return it as a sum, we return it as a depth. Right, and this returns uninitialized. Find result. Find result uninitialized and not found. Nope. Like that? Is it that simple? That's pretty clean, right? Oh, unknown field name, like, oh, just name here, right? Can't compare string with string. Can I do it like that? Oh no, star. I meant to put a star. Yeah. Okay, add local. Self locals borrow len greater than or equal to 256. Too many local variables in function. So do we have a locals count? I don't think we have it. The count is on the chunk. So we can add a locals count, right? Fn locals self usize self locals borrow len. And we can just say self result borrow locals. This becomes results. Push local. This is self. Oh, and we're going to check the scope depth. and then we're going to iterate on it and look to see if it exists. So, okay. All right, so we just wrote find variable, so we can use that. Instead of doing this business, we should be able to just say self if let find result depth of something, we don't care what, is equal to find variable, sorry, self result borrow find variable name. Then we do this. If it's one of the other two, then we can do this, right? And so the only thing we need to check on here is the scope. I was just looking at scope poppable, but that not only checks the length, but it also checks the scope. So we're just saying if the scope depth is not equal to 0. So we can just say if in scope, right, and return that self scope depth borrow is not equal to 0. So self result borrow in scope. Doesn't like that. Oh, this. Oh, that means we don't have to do this clone business. And now it's not in scope, right? Not self result borrow in scope. That was easy. What's the next error? And now mark initialize on the last one. Okay. What are we trying to do here? Trying to set the depth of the last entry to the length -1. And we're actually going to change that code a little bit. Remember from the last time we looked at that. I thought we changed the mark initialized. Yeah, we added this line here. So we still have to have that line. But not yet, right? Not yet. So let's concentrate on the refactor. Okay. What are we trying to do here? We're trying to see if we're trying to set the depth of the last one to the current scope. So we can just say self result borrow set local scope. And then just do this work in here. Fn set local scope of self. It doesn't return anything. The only difference here is that we have to borrow this guy. And do that. Oh. And this is another one where we're going to save not self result borrow in scope. If we're not in scope, then we're defining global. Otherwise, we're going to call mark initialized. That makes sense. In scope. Okay, we're getting close. Oh, this is doing the move. Okay, so this is where we can, I guess we could do this. Yeah, okay. No errors, no warnings. That's a good sign. We've done a bunch of refactoring work. And this should still run, right? Well, we have a couple of little test programs. Right, we can run our for test, cargo run, no default features, for test locks. Ooh. I thought I had a disassemble function inside the chunk. and I just put on no default features, so it shouldn't do. Oh, yeah. So, right. 98. This whole thing should not be compiled. Let's look at the other place we use it, and it's debug print code right there. All right. Let's try again. 1, 2, 3, 4. Okay, that works. And the other one was breakfast. I don't know what breakfast does. Oh, it just it adds 2 strings together. Okay. All right, so that's all work. That's still working. So what I've done is I've refactored in preparation for function declarations. Right, because that's where we were stuck last time, is trying to figure out how to do this. And now we can just use a replace call on the ref cell to get a new compiler. So let's commit these changes. Let's check in with Clippy. Clippy says this should be just stir. Okay. Sure. A bit of a refactor so that we can use replace when creating functions. All right, and then now we're going to actually do that. So now we're on function declarations. And I think I already read this, so I'm not going to read it over again. Compiler, fun declaration. There we are. So this is going to say if self is match, token type, fun, self fun declaration. Right? I don't know why I didn't do that. Okay. So that's all that does. And then after block, we're going to put fun declaration. And this should be a pretty straightforward translation. We say global equals parse variable, and then self mark initialized, which is now just down to this one line, but that's going to change. We don't have to pass in anything. Self function, and then this says type function, but we don't have a type yet. Because there's type script and there's type function, right? That's what we got last time. Somewhere. Scroll, scroll, scroll. I hate scrolling on stream because it gets hard for people to read and hard when I'm playing it back to see what mistakes I made. Okay. I'm just gonna, I'll leave this blank for now, and then we'll come back to it later when we need it. And then self-define variable global. Okay, so that's easy enough. Functions are first-class values, and a function declaration simply creates and stores one in a newly declared variable. Right. So we read through this, and then all right, and so here's where we need to do mark initialize. So if self, not self. Oh, yeah. This is doing a return if we're scope depth of 0. So if we can say if self in scope, then we can do this. We're in a scope, then we set the local scope. How come I can't find that? Did I not call it in scope? I did call it in scope. There's declare variable, there's parse variable, here's mark initialized. Okay. Good. Oh, because it's self-result borrow in scope. That's why that wasn't working. Okay. Very good. Okay, so now we're going to, after block, which is right down here, we're going to say function. And again, I'm going to leave this type out for now, and we'll see. Begin scope doesn't have the corresponding end scope call because we end compiler completely when we reach the end of the function body. There's no need to close the lingering outermost scope. Okay. So here's where we're going to use the replace, right? So we're going to say, we're going to start off by replacing the current compiler. Let previous compiler is equal to self.result.replace compile result default. So this generates a new compile. This does the init compile for us, and it keeps the old one around so that we can put it back in when we're doing the end compiler business. So let's see if this will actually work. Now when I call self begin scope, right, let's take a look at what begin scope does. It increments the scope, but now it's incrementing the scope in here, which is a brand new scope, which is a brand new compiler. So it's going to increment to 1. So we're going to be in a scope just for this one one function. We'll do the consumes. All right, I had undone all of the work I did at the end of the stream last time, but that's all right. After function name, and then this becomes a right paren. Change that to a right paren, and this changes to an open brace, and this becomes parameters, and this becomes before function body, and this becomes a left brace, like that. And then we call block, self block, and then we do this end compiler business, self end compiler. Now let's take a look at the way it's done. Constant, and then this make constant business, which I don't think we can do all at once. I think we have to go self let constant is equal to self make constant. We have that? We do. Of object val function, which is the function we extracted. Okay, so let's take a look at how we do this. Compile. So at the end of compile is what we do the same thing here. We call self end compiler, and now we're going to extract this stuff here. So these 3 lines basically. We do need to check for the error. So it's actually this whole thing, this whole chunk. And instead of returning the function, we create a new function that gets pushed on. Let func equals this with a new chunk. Oh, and this, now we need the actual function name, right? Where do we have the name? The name comes from I guess we haven't gotten to that point yet. But this gives us our function, and then we have to make the constant for it. Let constant is equal to self make constant value func. All right, so this is how I'm translating it. Let's see if it builds. 25 errors. Oh, I probably forgot a closed brace somewhere along the line. Yeah, I did it there. It usually tells you, oh, here, 763. It says this one might not be, oh yeah, I forgot the else. Okay. Oh, and this doesn't report an error. This just is going to return. So we can do it this way. Oh, this has to be mutable, right? I forgot. There, two warnings. Oh, right. We have to put the old compiler back. So we just have to say self result replace previous compiler. I think we have to do that right after end compiler, because all this stuff. Ooh. Yeah, so let's do that. Let result is equal to this. And then we have it here. Okay. Okay, good. It's a good thing they Russ warned me about that, because we needed to do that, right? We need to extract the result of this compilation, and then here, if there was no error, we emit the code for it. We emit the code in the previous compiler, the constant for the new function, right? Because that's what end compiler does here, is it puts the old compiler back and then emit bytes on the new. So we make a constant on, on the previous compiler, not on the new compiler, and emit bytes in the chunk of the previous compiler. For now, we won't worry about parameters. We parse an empty pair of parentheses followed by the body. The body starts with left curly brace, which we parse here. Then we call our existing block function, which knows how to compile the rest of the block, including the closing brace. This compiles. I think we're not done yet with everything, but we should be able to cargo run and still create a function. We did. So if you look here, so this is one of the issues we have right now, is we don't have the variable name, and that goes here. All this is doing a return, right? Let's try actually putting some code in there. Fun foo var a equals 1 print a. Yeah. So this is defining a constant of 1. It's getting the local, right? Which 0, which is what a got translated into. We have the print, and then we have the return. And then in our main, quote unquote main, we're actually executing it here. Although it doesn't do anything because there's nothing to execute. This shouldn't be running anything. So I think, oh, I see what's happening here. What's happening here is this is what the outer script is doing. It's defining a constant 1, which is the script, which this should say foo, right? We don't have that hooked in yet. We define a global called foo, and then we return. So that's all the outer script is doing, is defining a function. Neat. Okay. So I think we're getting there. We're moving along. Right. This is the stack of compilers which we did. Instead of doing it this way, the way they have it in C, of creating this linked list of compilers, what we're doing here is just using the stack of the Rust's stack to keep track of all the functions, right? We store the previous compiler here, we do all the compilation we need, and the previous compiler is still on the stack, and we can put it back in when we're done. So that's the equivalent of linking the enclosing one to the current and then pulling it out again. It says, note that we don't even need to dynamically allocate compiler structs. Each is stored in a local variable on the C stack. And you can see that right up here. And so I'm doing the same thing. I'm storing this on the C stack, on the Rust stack. Okay, so now we can do function parameters. Functions aren't very useful if you can't pass arguments to them. Okay, let's actually commit these changes before I do anything else. Git status. Git add. Source git commit. Section 24.4.1. What do we call it? A stack of compilers. I guess we're starting function declarations. Functions. Stuff. Function stuff. There you go. I'm great at naming. So let's do parameters next. All right. So now in compiler inside function, we're going to check to see. Oh, okay. We're going to look for arguments. Oops. Come on. There you go. So this happens between the two consumes here. So we see an open paren, so a left paren, yeah. And then we say if not self check token type right paren. So if the next thing is not a right paren, that means that we must have our arguments. And this is a do while loop, which we don't have in Rust. We can kind of emulate it by doing loop and then using break, lop. So we can say current function's arity increment. Let's see. How is this going to work? Because right now their current function is in here. And it doesn't exist. Should I be compiling into a function? Would that make more sense? Instead of doing a chunk, I can make this a func, which would mean more refactoring work. Okay. Let's see what that would take. Function. The function has an RC chunk, which means, oops, I didn't mean to do that. Did not mean to do that. Okay, if I do this, though, every one of these chunks has to change in this compile result. Right, all the way down here, we're going to have to say func borrow mute chunk dot write. Func borrow chunk dot count. Func borrow mute chunk add constant. So this might be a pretty straightforward refactor because it's all going to be in here, right? Oh, and then in the initializer, func chunk, func chunk. Yeah. So then when we're done compiling, we need to get the function. Oh, do we have a way to get the chunk out? Oops, this should be function. We do have an RC clone of get of func. So if I say result.func.borrow.get chunk, oh, and then we do RC new on chunk. Doesn't like that because it expected a chunk and found an RC. So we, oh, okay, we can just clone it then, right? We can say RC clone chunk. And now we have the same problem here inside function. So we do the same thing. We have chunk is equal to func.borrow get chunk. And then we do this, clone chunk. And we still have one error, and that error is, oh, we don't have a default for function. Oh, are these all bad? That's a shame. That's a shame. So this whole that whole refactoring is not going to help because we can't modify the chunk unless it has okay. Wait a minute. If I do that, then I have to implement something inside func that does all this. Right? So if we do a chunk write, we need to be able to write into the chunk, which means the chunk. Let's take a look what the chunk looks like. Yeah, we need to be able to modify code and lines and the constants. And I don't want to make all of those into ref cells. So if I make the function have a ref cell, right? That's where I was going. That would mean that we would have to add code here in function to do these operations. Okay. Pub fun, right? It's just these same function signatures here. Count, add constant, right at, and then disassemble. Okay, so this becomes self.chunk. And this becomes RC clone. Like that. Ref cell. Unless I call this extract chunk, and then we can return the. But that would mean the function would. Okay, well, let's try it this way and see, and then I can call it extract chunk if it looks like that's safer to do. Or mute, right line. Oops. Getting ahead of myself, right? Self chunk borrow. Then self chunk borrow mute. Add constant value. And then self chunk borrow mute. Right at offset use byte. And then this becomes self chunk borrow disassemble name. Let's see what blows up. Oh, we don't have value? private associated function. Oops. So all of those need to change. Func. Borrow. Let's take a look at what chunk looks like. What are we looking at? Code, I guess. Was there a len already on it? Count. There's a count on it. Okay, and now here we are, expected RC chunk, but we got RC, we got a ref cell. So we can put a borrow here. Oh. Oh. Where is this used? GR? All over the place. Oh, right. This is how we access the chunk to figure out what's happening now. Okay. So get chunk now returns, yeah, and we can't do extract chunk because we pull it all the time. Ah, that's a shame. So was that a bad refactoring then? Source function. What would be a better approach? Compiler. So the reason we're doing all of this is so that we can get access to the function's arity. That's the whole point of doing this. And I wanted to set, I said, okay, well, let's stick the function directly in here then. And that way we have access to all of the bits and pieces of the function. But apparently that's not the best approach. And I don't want to stick the arity and the name. I guess we put the name here already. We could just put the arity here. Then it's not really part of the function anymore. Or it will be once we extract it from the... All right, let me put this back to chunk. And that changes all these guys. And then in the compiler, what was this before? Chunk. Replace. Chunk new. Right? And this is new chunk. Oh, right, and we have to change this now. The function has to go back to being a RC chunk. But now all this stuff goes away. Yeah, I fixed that. Oh, this guy here is now expecting a ref cell. Okay, never mind. Right, and then this needs to be chunk replace, chunk new. Oh, this has to be new. And then RC clone, oh, this is no longer a ref cell. There, okay. So now we're back to where we were before. Oh, right, function doesn't use value anymore. And ref cell, okay. All right, so now we're back to where we were before. Now the question is, how do we handle the arity? And I was thinking, well, we could just stick it in here as another ref cell. Just like we have this guy. Let's move him down too. Ref cell usize, I guess. And then when we create the function, we can create it with the arity that we extract from here. Right? So then we need a function here to increment the arity. Error at current. What's the difference between error and error at current? Error, fn inc arity self. I guess we can return the new arity self arity borrow mute plus equals 1. I forgot the star, and you just return it. Right, and then in function, we can say if self inc arity is greater than 255, self error at current can't have more than 255 parameters. Oh, this is inside the loop. Okay, and then we're going to say let constant is equal to self parse variable. Like that. Self-define variable constant. If not, self is match, token type, comma, break. So that's how I'm doing the do while loop. That's the while thing, and we don't have any continues in here, so we don't have to worry about that part of it. And then let me take a look here at error at current to see what this is doing. It's just calling error at, and it's passing in the current token as opposed to the previous token. Okay, so this build, it does not, because I'm returning arity. Oh, borrow. Right, and now I don't have this anymore. Okay, so at end compiler, I'm passing in the current function's name, and that's been moved into result. Self result borrow. There. Okay. So that's that part, right? So we're generating this arity. We're going to have to pass this in when we create the function here. We're going to have to pass all of that in at some point. We're going to have to pass in the function name, which we still haven't set. Right? That hasn't been set anywhere. And we're going to have to pass in the arity. So we're going to have to change the original one. Just say new top level. Because normally functions will have arities and names, but the top level does not. Top level is only the chunk. And that's this guy right here. Semantically, a parameter is simply a local variable declared in the outermost lexical scope of the function body. We get to use the existing compiler support for declaring named local variables to parse and compile parameters. Unlike local variables, which have initializers, there's no code here to initialize the parameters variable. We'll see how they are initialized later when we do argument passing in function calls. Some languages do allow you to initialize, right? Rust doesn't, but you can say foo, and then you could say b usize equals 27, and then give it a default value. So if you don't pass it in, then it becomes 27. But if you do pass it in, then it takes the value you pass in. While we're at it, we'll note the function's arity by counting how many parameters we parse. The other piece of metadata we store with the function is its name. Okay, here we go. So in an init compiler, we say if it's not a script, then we're going to save the name. And the name is going to come out of the previous parser's lexeme. So, and that's in init compiler, but we're not doing that here. What we're doing is function. All we're doing is saying replace the current with. So that means at this point here, we should have this parser previous start and parser previous length, which is the name of the previous lexeme. So I should be able to say self result current function replace with self parser previous name lexeme dot clone, maybe. Oh, borrow. What? Oh, it's still a string. Ref cell. And now we should be able to say borrow here. And it doesn't like this. Previous, it's a token. Token has, oh, it just has the lexeme directly. It doesn't have the name. Okay. 605. I don't have to put name in here. There. And we have two warnings. Right. We're not actually putting it back. So we have to do that here. Self results current function replace with previous name. Previous name? Yeah, previous name. Borrow. This is painful, isn't it? Okay. So that's this part here. So now we should actually see the function name when we do the disassemble. Do we? Let's find out. We see foo instead of script. Remember before it was saying script, but now we're seeing foo. That's good. So we're getting there. This still says script here. I'm not sure. Oh, because I'm not setting the function name yet. Yeah, when we create the function now, let's fix that while we're here. Uh-oh. Why is there no function? Did I delete the function? What happened? Oh, that's probably a very old... Wow. I had a very old thing going on here. Wow, that scared me. Okay. There's an old editor that I have stuck in the background and I hadn't done anything with for forever, and then pulled that up and blew my brain away. Okay. We're back to normal. Oh, so we should actually be able to print it out. That's what they're saying here. Okay, so what I need to do is fix this. Let's fix the function creation here. When we create the new function, we say function new, we should be able to say, Let's split that and then say function, and then function new should take all three parameters. It should take the chunk, the arity, the chunk, and the name. Like that. What's the use size? Yeah? Yeah. Okay, good. And then we're going to say pub fun top level. And that's just going to take a chunk, which is what we had before. And return a self. And that has an arity of 0. Oh, this should be self, like this. This is where we get arity of 0. So we clone the chunk, and then this is a double quote. Okay. So then here we're going to say new, but the other place, this is the top level, which just takes, right? So we compile the top level thing here, and we just return the chunk, and it doesn't have a name. And we have 4 errors. Self. Right, so now here we pass in the arity. Self results arity borrow. And then finally we pass in the name, which is just self let new name func name equals func name. Okay, and I'm gonna change that because that's ugly. I'm gonna make a get arity. And so this just becomes arity like this. Without a star. Good. Okay, so now we're there, and now I should be able to do this, right? I should be able to say cargo run fun foo this print yes. I don't know. I don't care. And then say print foo. That did not work. Why did that not work? Here we're defining foo, which has a constant yes, and it prints it and returns. And then we have our top level, which is just script. Well, got to fix that. It defines the foo function and returns. And then when I print foo, I have top level, which says get global foo print return. This is what the compiler does. Oh, I see script. I see extra scripts here. What it was executing was constant define global foo and return. It wasn't executing what we just compiled. And there's an extra script on the stack. Really? Extra script on the stack, you say? Well, we do push the function here. We set up the call frame, and then we run. Do we have to pop it off? Do we have to, after we run it, do we need to pop it? Oops. Did I just miss that in the previous? Oh, and then this has to return result. All right, let's define this again. Print foo. Aha! It's not working, but we're getting closer. So I fixed that bug. That was it, right? Git add that, git commit, pop script off stack after running it. But this isn't saying function foo. This is just, it's saying script, which means the name is not getting in there somehow. Although we are seeing it here when we disassemble. Can I call it? Let's try that. I'm just trying to, whoa, why did I do that? That's not good. Let's fix this. That means this is over here. We have to pull this down. I don't know what keystroke I did to make that happen. Grab that and shrink this down to 100. Again, there we go. Okay, we're back to where we were. We do that. Can I call it? No. Okay. Oh, because we haven't written function calls, and I can't print it, or it's not printing because we're coming up with script instead of foo. It is saying get global foo, and then is throwing a script on there. So let's see. Let's take a look at the VM where we print the stack out, because we do that in our debug trace execution. We have self stack. We print the slot. Does that mean in our functions display we're not? Yeah, name is empty. Huh. Println creating function with name. Can I do that without the toString working? It does not. Okay. I have to do it this way. There. So now let me just copy this again and see if it's creating the function with the name. Yep. Creating function with name empty. Ah, I did something wrong. Prev name. Oh. Yeah, so I grabbed this and I stuck it in here in the current function, and then when I pulled it out, it should have been in there. Okay, well, let's debug that. Func name equals blank. Prev name equals blank. I was expecting. Func name equals blank is not what I was expecting. So that means maybe this doesn't work. This parser previous lexeme. Maybe that's empty. Let's print that out. Oops. Println parser previous, like that. Okay. No, so it's parser previous is foo. So what's going wrong? Let's see what I did wrong here. Proof name. Okay. The current function replace with this guy, which is what we're expecting to see. We're expecting to see this be foo. Then when we come down here, we replace it, we put the previous name back, we should get the func name that we put in there. I guess we can, Why is that not working? Because we have a ref cell in here. Oh, this shouldn't be debug print code anymore, right? Because we're using it all. We're using it for real now. That can't be the bug, right? Yeah, I'm expecting this to say foo here under func name. After we re-extract it, we swap it back in. It should be in there. Oh, wait a minute. This current function is part of the compile result. And I'm putting a new compile result in here. So we should actually have it inside. Okay. So I don't need to do this. I can put it in there directly. I get it now. I put it in there directly with this, setting the name. Actually, what I can do is just say compile result and give it the name here. That would be cleaner than doing it in 2 steps. And then when we pull it out, we don't need to pull the func name. We can get it directly out of results. We can say result.borrow. Oh no, it's already compiled result. We can say result.current function.borrow. Yeah, and that should work. And then I'll clean this up in a second. Let's clean this up. Source. Oh, we can just run it, right? Creating function with name foo. Okay, so now we see function foo. I say print foo. We see function foo. Perfect. Okay, that's that bug fixed. Okay, now let's take a look at compile result. And instead of having a default for it, or maybe in addition to having a default for it, right? This is we're going to have a default. Here we'll have a default. But here we can say prefix compiler compile result. We're going to give it a name. We'll just call new. And then just, we don't need this, and we don't need this. Right? Like that. We should be able to do it all in one swell foop just like that. And then I'll just put the new here. Fin new self. It becomes a self of, give it a name. I guess we can do this same thing, to string. Name t, and self becomes current function is name to string, and then default like that. It doesn't like that. Oh, ref cell new. Yeah, okay. And then compile result. Default, and new. And we give it the name, and we extract the name here. Let's make sure that still works. I see function foo here. I see function foo here. I think we're good. All right, so we managed to muddle our way through that one. That was section 24.4. Let's see if Clippy's okay with everything. It is. Git add source, git commit. Section 24.4, and it was called function declarations. Good. All right, so then tomorrow we will work on function calls and get those working. Tomorrow? Yes, I can stream tomorrow. I can't stream Wednesday, but I can stream tomorrow. Okay, very good. What was the other thing I wanted to do? Was talk about briefly. Oh, that was Lua. There's the Fill OS thing, and I don't remember where that was. Fill OS Rust, yeah. And so this is what I'm going to start working on next week, and alternating with the crafting interpreters until we're done with crafting interpreters. Is working on this, writing a full operating system in Rust, using a VM. It walks you through creating a standalone binary, which is this no standard, which I haven't done before, so that's going to be pretty interesting. And then being able to run it inside a not VMware, but something similar. Like, where does it? Yeah. I'm trying to. This is cool. Yeah, it's cool. Okay. I'm just trying to figure out what I'm going to need to install. So we need Rust Nightly. You can see that here. It's an LVM of unknown. And then we're going to run it inside. Yeah. We're going to have to use Rust Nightly. That's fine. So we're going to work our way through all of this. It needs a bootloader, and then we have it put it running in. That's it, QEMU. So that's what we're going to be using, QEMU, to write an operating system in Rust. And it's going to handle VGA test mode. We're going to handle how to do tests, CPU exceptions. We're going to do memory paging and async, and then that's that. And so it's kind of neat to be able to do that. There's a bunch of stuff that you would also want to have in your OS, like a file system, for example. That's missing. But that'll be fun. And maybe we can add a file system. Maybe that would be a good project. Okay. So what we have here, we will push and take a look at. Not here. Here it is. Yeah, so we refactored. Well, that was a bunch of refactoring we did in order to get the compiler to be inside this compile result thing and keep this parser, the scanner, and the rules separate. After we did that, we finished section 24.1, 0.0 and 0.1. And then I fixed a little bug in our VM. I'll have to look to see what I missed. And then we did function declarations. So now we can declare functions with parameters. At least we should be able to. I didn't even try it. Yeah. But we can't call functions yet. That's going to come in the next section. We're going to do that tomorrow. Function calls. All right. Well, thank you everyone for hanging out with me. And if you watched it on YouTube, thank you for watching it there. And I will see you tomorrow with function calls. All right. Take care, everyone.